Welcome everyone. Thanks for joining the Loc8 live webinar. Let's see. If you're joining, I'm going to share my desktop. And we'll probably get started in about a minute once we go through all the technical challenges. All right. So hopefully you guys can see my desktop. Right now, all the lines are muted for now. If you do have any questions throughout the webinar, feel free to use the chat function that's available on your screen. You can also ask questions as well through that format. Right now, I see we have a few on. So for those folks that have joined, I'm going to go ahead and get started. There's going to be a few stragglers, but I wanted to be respectful of your time. And so we'll go ahead and get started. So thanks for joining for today's webinar. My name is PJ Kirkpatrick. I'm one of the co-founders of Loc8. We also have Gene Robinson. He is a drone search and rescue subject matter expert helping out today. If you don't know Gene, he has over about 15 years of experience using drones for search and rescue, and actually has been an invaluable resource as we've developed a graphic user interface and has also helped out with testing. Gene, did you have anything that you wanted to say today? Introductions?
Yeah, PJ, it has been a real pleasure working with Loc8 and all you folks, and it's been a godsend to me in the search and rescue world. As you know, I have looked for this for years and years and years. And finally, this is the piece that we have seen and we knew would be out there. So looking forward to continuing working with you guys. And if there's anything else that I can do to help you, know I'm going to be there. So
Absolutely.
Let's get this show on the road and get some folks educated.
Game on. Thanks, Gene. So just a little housekeeping. If you have any questions, as I mentioned earlier, just type them into the question box in your control panel. We're going to try to address them during the presentation, but we'll also have time for question and answers at the end. So without further ado, we'll start with a few slides, provide some background of Loc8, followed by a live demonstration of the software, and then again finish with some Q&A at the end. So let's get started. I'm going to bring up the presentation right now, bear with me. All right, Gene, can you confirm that you can see this on your end?
Yes, it's clear and ready to go.
Awesome. So I wanted to highlight some of the studies that have been found out, that we found out there, basically that using your visual human eye, it is fallible in some regards. And one of the reports stated that target 30% of the time is actually, they're only capable of viewing those images. And I can tell you from experience, I've found myself having eye fatigue as reviewing images manually. And so our goal with Loc8 is actually, increase the success rate and the processes to locate your target, whatever it is. So in a nutshell, what Loc8 does, it's a computer program that scans the images, looks at every pixel in the image. Now the pixel or the computer program doesn't care what you're looking for. It's ones and zeros. So when we look at pictures, the human looks at pictures, we see a pretty object. The computer is just looking at numbers, right? So systematically scans each image, and then I'm going to walk you through the workflow as I get into it. So I'll go into a little bit more detail of how this computer program is actually going through it. So I did want to highlight that some of the slides coming up are considered graphic and disturbing. So If you have a weak stomach, feel free to either drop off or go ahead. So I was gonna highlight, if you folks don't know how Loc8 actually started, it's actually the result of a failed search and recovery mission. Give you guys some background. There was a law enforcement contacted us about 5 days after they had used cadaver dogs, helicopters, volunteers, and law enforcement personnel around a suburban area of a suspected suicide mission. What we did is we conducted a methodical mapping mission to collect data, and then we reviewed the data manually. There's about 3,000 images that we looked at manually. So this is the area that we targeted. The yellow dot in the middle of the screen is where the cadaver dogs kind of had hits. We didn't have a lot of information. We didn't know what the subject was wearing, anything like that. So it was kind of based on experience and understanding the terrain of the area. So these are we broke them out into 5 areas, simply to maintain visual line of sight of the drone as we were flying. One thing I wanted to highlight here is there's about 2,400 images that we looked at manually. We actually flew this around 250 feet AGL, above ground level. Mainly we wanted to balance flying low enough, but also clearing all the obstacles in the area, and as well as time and stuff like that. So it's a full day of flying. This is an example for those that are new to mapping with drones. This is a simulation of what the drone's kind of doing, as it's all automated. Basically, create a polygon area that we want the drone to fly around. We select the speed. Now in this example, the drone is kind of like looking ahead, but as we map these, and that you'll see on the next slide, we actually recommend flying these missions with the camera at nadir or pointed straight down. Also, we also recommend using about 80% overlap, and this is to ensure that we don't miss anything in the images. So again, this is just a Google Earth simulation of doing that. So there's a myth out there, I think, that people think it's really easy to spot targets in real time. This is a simulation of the images that we've stitched together in Pix4D and flying. And as you can see in this example, there's a lot of noise in the background, which makes it very challenging to identify targets in real time as you're flying. In addition to that, keep in mind, if you're out in the field, oftentimes there's glare on screens, stuff like that. I'm not saying that it's not advantageous to have that as a resource, but it's not recommended to just rely on real-time scanning process from my experience. So this is one of the images that that I reviewed and I totally missed. So about what happened was 5 weeks later, we got an email that stated that, hey, they found the victim in plain sight. And once I found out where it was, I'm like, I'm pretty sure we flew that area. And so this image actually has the individual in the area. I'll let you guys kind of scan this image and see if you guys can find him. When I remembered this image actually, and when I scanned this image, and keep in mind there's about 3,400 images, so I spent maybe about 5 seconds per image. And I remember scanning this area to the right in the field, and I neglected this area mainly because I speculated that it was a high traffic area. This is the entrance and exit of the subdivision, and I actually drove down, straight down this this area here. So I'll give you guys a hint where this target was, is behind this entrance of this wall, and I can zoom in a little bit. So the target was laying down, part of it, legs were underneath the brush. So it was actually kind of hard to see from the air, even at the elevation I was at. So what I did was I actually went into Facebook group, search and rescue Facebook group, and that's where I kind of met up with Shane Michaels from Wings of Mercy, and I had asked him, hey, can you run this data through your software that he was developing and working on? And in about 30 minutes, and at the time it was about 3 seconds per image, he was able to identify the location, which provided latitude and longitude of this target. So the red dots you see on the jeans, basically what Shane did is he took a picture of his jeans that he was wearing and made kind of a guesstimate that a lot of people wear jeans, and in this case it worked. And so that's how my relationship with Shane started, and the rest is history. So a few days later, after finding out, I drove by there. This is how far the subject was from the road. So for 5 weeks, people were passing them for 5 weeks. So it's unfortunate, but as a result of that failure, we think we've developed a process that will help future search and rescue and recovery operations going forward. So I was gonna ask you guys a quick question, or a few questions. So I'm gonna open up a poll right now. So yeah, I'd like to ask everyone to select their best answer. So according to data from NAMIS, how many individuals are reported missing in the United States each year? I'll give you guys some time to go through that. Let's see, I got some. A few more people need to vote. All right, so I'm going to share this with everyone. All right. So let's see, if everyone online guessed 400,000. The actual answer is 600,000. So I was actually kind of surprised that number was that high as well. But 400,000 is a good guess, but yeah, the actual answer is 600,000. Let me close this. All right. So yeah, what NAMIS stands for is the National Missing and Unidentified Persons System. Also, the National Park Service, they provided some information as well, and their statistics highlight about 884 million acres of parks. And from my perspective, I think drones are a pretty good application and tool to use for aiding in search and rescue and recovery missions. I'm gonna ask one more question. Let's see. What are the most common places for search and rescue or recovery missions? Again, I'll give everyone a little time to select which area. Is it the desert, mountains, rivers, or oceans? Give it a little bit more time. All right, I'm going to close that out. Share the results. And in this case, everyone was right. The mountains are actually the most common place for search and rescue missions. And between 500 and 1,500 feet, which again, I think is a outstanding place for drones and even manned aircraft to use for search and recovery missions, simply because it's more challenging to get to those areas. So this map is kind of what traditional methods of highlighting areas searched are. Oftentimes on the news, when the reporter's interviewing either the victim's parents or they'll show a map of the area, and this is typically what's been used in the past. One of the things when we talk about data acquisition using drones, as I mentioned, it's a very methodical process. So here's an example of a methodical process on the upper left, and on the right-hand side, the red dots indicate the location where the images were captured with the drone. And in this case, an individual was saying, so you guys think that we can clear this area? And the comment was made, well, if this was your son or daughter that was missing, would you consider this area clear? And another way to look at it, and actually Gene, if you want to bring up that other way that we talked about, you had an interesting perspective of this example.
We'd always considered when we sent search teams out and got an idea of how methodical they were, we would ask them, if we put 10 items in your area, how many would you find? And there were many times that people would come back and say, oh, well, we would find, 7 or 6 or 8. And I always wondered, and I always posed the question, is that 70% good enough for you? So that was how we tried to instill on people how important it was for that methodical, very thorough search to be performed.
That's an interesting way to look at it. Thanks, Gene. So touching on that, this is an example of the location of the images that I captured as I flew my drone. So before I kind of go into the next slide, there's a couple more questions I just wanted to ask as well. So this information is very interesting. So what is the average distance of suicide victims ages 25 to 35 from their place of residence? Give everyone some time to answer that one. And I'm going to ask Gene to weigh in on this one. So I'm going to close that and share the results. Gene, do you want to share the answer with everyone?
Yeah, actually, it's just under 1,000 feet. So most of the searches that we perform, and you'll hear this coming up, is the 900-foot search, because that's where most of this age group has been found if they are victims of some sort of mental stress or duress and are contemplating doing themselves in. And we have found that this to be pretty accurate in a lot of cases, even outside this age range. So it's been pretty close.
Thanks, Gene. And there's one more question that I have for everyone. What is the average distance of discovery for missing persons in all cases? Give you guys some time for this one. All right. Whoops. Let me share the results of that. And Gene, you want to go ahead and share the answer with everyone?
Sure. It's interesting to note that even people who are not wanting to be missing, or they're not willfully missing, that are actually in need of assistance, typically make it no further than about 2 miles from the place last seen. And this has been supported in several different research papers, and some analysis has been done for some very good, very smart people. And this is the case. However, when you consider that 2 miles radius, when you start with that probability of area, is still a significant amount of geography. And that's why it is so important for us to be able to utilize drones effectively in the imagery it produces. So that 2 mile radius ends up being just under 4 square miles.
Thanks, Gene. And in my case, let me go to the next slide here. As I mentioned, this is the area that I had flown. And you can kind of see how close I was to actually identifying the location of this particular individual. With that said, the stats that Gene had shared with you prove to be accurate. And I'm not going to show the exact location of their residence in this example, but I can tell you it was within those numbers that Gene had shared. So stats don't lie in this case. So before I go into the real world or real-time example of Loc8 software, I want to highlight where the data was captured. So this is a simulation that we did near the NTSB training facilities. The data was collected at 120 feet above ground level using a Phantom 4 Pro, and the mapping mission was a single grid mission. And the reason it's so small was just because we had about 50 students that day, so students were flying, throughout the day. So to give you an idea, and in this case, there's about 133 images that we're going to go through in the example. And with that, let me move my screen so I can open up the software. So when you first open up the software, this is the GUI interface that you'll see. The first thing that we're going to do is just set up the file structure. So we're just going to give this one a name. I'm going to call this NTSB missing demo 1. Next, we're just going to identify the results folder. So this is going to be the folder that that all the data is going to go to as it processes the information. So for example, you'll see when I get into it, we're going to be archiving images, we're going to be flagging images. And so this is the folder that where all that information is going to go, reports as well. Next, we're going to select the location where the images are that we want the computer software to scan. So I typically the naming convention I use, I always like to number mine. If anything, it just makes it a little bit simpler to sort them. So all the sample data, as I mentioned, is single grid at 120 feet AGL. I'm going to select that. So once we have our file structure set up, now what I'm going to do, we call this the Bloodhound Technique, where we have an existing image of the missing individuals, and we're going to extract that color from that pixel from that image. So we're going to select the viewer button there, and it's going to open up this viewer window. And this is actually previous previous test I did prior to make sure that this will all work. So I'm going to open up a image. I'm going to open up, let's see, subject image. So these are 3 dummies that we used during the training. Sorry, that's myself in the middle. So the first thing we're going to do once we have this image, I had taken this with an iPhone 10 camera, or phone, I should say, using that camera. And the reason that's important is because the drone has a different camera, it's taken at a different time of day, and that's why we want to use a color range. But to get to that range, the first thing we're going to do is zoom in as close as possible, and you can kind of see the individual squares. These are the pixels that we're going to extract the colors from. And there's a couple different techniques you can use to do that. We have this window technique where I can just right click on my mouse and scan a window and extract the average pixel value there. Another technique you can use is you can actually select each individual pixel if you want, and I'm going to pick a range of colors, pixels, and I'm going to show you a technique that I like to use in addition to the window technique. So after you select about 3 pixels, I'm going to create a range. Select the create range button and call this demo 2. That's going to open up this range window. So each value has 3 values: red, green, blue, RGB. First thing I'm going to do is average those. So if you kind of look at these numbers, 89, 127, 167, and as I mentioned, that was taken with one camera, and we're going to be collecting data with a different type of camera. So we're going to create a range for the computer to look at. So as it's scanning images, anytime it sees a pixel, it's going to flag it. So the default is 10. So what this number represents is when I select convert to range, you'll see the 89 is going to turn into 79 and 99. So it's plus or minus 10, so that you're kind of spreading that color range, making it a little bit open, so to improve the success rate of finding those colors. So we're going to accept that. We're going to close this out. Then we're going to go back into the first GUI interface, and we're going to add that color palette that we just created. And I think it was the demo 2. Open that up. And I can just review this, make sure it's about right. Yeah, that's right. And the reason we have this additional step here for the Spectrum databases is because as we continue, we plan to develop a Spectrum database, right? So that if you don't have the picture of the individual, but you know what they're wearing, let's say that it was described as a red shirt, dark blue jeans, or tan pants, we can use those images and extract or create a color palette just for those to kind of speed up the process if you don't have that information available out in the field. So now that's all set up, all we have to do is hit the start button. So it's going to start scanning. So what I'm looking for right now is this images saved area. Right now it's 0. Right now it's looking at each image. It takes approximately 1 second per image to scan. And you also have this window here. You can kind of, as it's going, and once you have a lot of experience with the software, oftentimes if you have a color palette, you'll see that, oh, you're getting hits for every image. Once you see that, then you can go back to your settings, and there's different levers you can do to reduce the some of the failures that it's seeing. Or so about 16 of 133. Anticipating a hit soon. Anticipation's killing me. Okay, we have 1 hit so far. So once you see a hit, you don't have to wait for the program to finish before start analyzing the data. We can start analyzing the data right now as it's continuing to scan. So the first image I'm going to see is it puts a red circle around a hit. So there's 2 things you can do. You can either zoom in with your mouse, but we wanted to make the process significantly more efficient. So you can either click this button or hit the Z button, and it zooms into that area. Now remember, the computer program doesn't care what it's looking for. It's just looking for a color palette. So in this case, it identified blue flag that's on here. If I zoom in a little bit closer, these are these red dots. And if you need to see the original, you can click this button to kind of move your mouse around. You can kind of see what those numbers are, and that's more for troubleshooting as you continue to scan for other techniques. The other thing, we don't want to delete any of this data. So how the workflow works is we can either archive this photo and save it for if we need to reference it later, or we can flag it as we think this is something that requires additional investigation. We're going to archive this one by selecting the A button. Again, because we have about 80% overlap, there's going to be a few images that appear like they're the same, but they're off a little bit. This is not what the item that we're looking for, so we're going to archive that one, archive that one. Now this one looks interesting. We're going to zoom into this one, and here we go. We have a successful hit of the missing dummy that we're looking for in this case. And so the next step, what we do here is we don't have to wait for again, because time is of the essence in some cases, that we don't want to wait to try to pass this information on to either the incident command or whoever's in charge. So there's a couple things you can do at this point. On the lower left-hand corner of the window, we have the latitude and longitude. This information can be provided to the incident commander or whoever's in charge. And keep in mind, we've developed this software to not be dependent on the internet. However, if you do have internet access, there's a button that says Show Map. If I click on that button, that's going to bring up Google Maps. And what's nice about Google Maps is it provides you the location of the latitude and longitude that you saw in the previous window. You can put the satellite information on here. What I like about it too is you can quickly share this information to folks that are out in the field. Just select the share button, you can text it to them, you can email it to them. And like I said, this is just a kind of a way to pass that information relatively quickly to whoever needs it. So I'm going to continue just going through the workflow. So in this case, we're going to flag this image because when we run reports, you'll see at the end, I'm going to archive this image. I'm just going to go through a few of these. The other thing that's really nice about the zoom to object feature is if you have multiple targets in your window, you can zoom through each one of those and it goes to the next one. And when it's done looking at each of those targets, it zooms out so you know that you identify or you reviewed each of those. So we're going to archive that one. Archive that one. We are going to flag this one, flag that one, flag that one. And so for the sake of time, I'm going to stop here. I'm going to go back to the scanning window. I'm going to stop it for now. There's a couple reports I just kind of want to review. First one is this quality report. It's going to be a PDF report that's going to be brought up. So this gives you information about the analysis itself, provides you the name that you called it, start and end time, how long it took to process the data, which search method was used, the color database if you need to reference what color palette was used, how many images, things like that. Another report that I like, and this one is probably the most important one, is if you select the viewer button and then go up to the upper left-hand screen and select File, Generate Output Report. And again, this is going to save it in the output directory, you should. And it's going to pull up another PDF report. Now, all those images that we flagged, it's going to bring into the report. Whoops. And from here, if you don't have internet access and you need to pass on this information to incident commander, whoever's in charge, this is a report that references the photos. It gives you kind of a thumbnail of that photo. It gives you the latitude and longitude, and it gives you the link to the Google Map location as well. So you can put this on a thumb drive if you need to maintain a chain of custody. Don't need to put anything in the internet. So that's another method to pass on that information. And so that is essentially the workflow of the Loc8 application. I'm going to go back to the presentation real quick. So with that, I am going to open it up to questions at this time. And Jean's going to help me sort out through those questions. So if you have any questions, just type it in the chat box. And I'm not going to call anyone out by name, but I see folks on here. I give you guys some time to ask questions.
Well, when you explain it as well as you did, kind of hard to ask questions, isn't it?
Yeah, either that or they're shy. And if you have a question and you don't want to ask it now, by all means, I'd like to direct you to our Loc8 website. that is going to be available at Loc8.life. We do have a knowledge center that we're developing, or that has been developed, that as questions come in, we're posting answers to a lot of those questions on our website. You can also ask a question through the website as well. So there's multiple ways to get your questions answered. And if there's no further questions, I'm going to end the webinar. But before I do that, I'd like to thank Gene Robinson again. Thank you, Gene, for all your help with this, and definitely looking forward to collaborating with you more in the future. And I'd like to thank everyone that attended. And like I said, if you guys have any future questions, by all means, please visit Loc8.life, and we look forward to collaborating with everyone. Thanks everyone for joining us today, and talk to you soon.